So you know that incredibly annoying buzz or hum you get when an audio cable accidentally crosses over a power cord behind your TV.
Oh, yeah. The worst.
Right? It's a super frustrating little irritation at home. But I want you to imagine multiplying that exact same electrical interference by the size of a massive stadium concert.
Well, at that scale, you really aren't just dealing with a buzz anymore. I mean, you are looking at an absolute catastrophic audio failure just waiting to happen.
Which is exactly why we are bringing you this custom-tailored deep dive today. We're looking at this really specific piece of gear from HDTV Supply. It is called the Thor Broadcast F-16A-RCA-TxRx.
Quite a mouthful.
It is,
Yeah.
but it actually kills that electrical interference entirely by turning standard audio into light. So our mission today is to figure out why the professional AV industry is just, ditching heavy copper wires for fiber optics entirely, and how this gear actually solves those logistical nightmares.
Well, the core of the solution is really right there in the mechanism itself. I mean, this Thor broadcast unit takes 16 independent channels of standard line-level RCA audio, and it just completely converts them into optical signals.
But wait, how does converting audio to light actually stop the hum? I mean, what is the actual mechanism there?
It all comes down to what copper wiring actually is fundamentally. A long copper audio cable basically acts like a giant antenna.
I'm sure. So it just absorbs whatever is around it.
Exactly. It naturally picks up ambient electromagnetic fields from, nearby power lines or generators or massive lighting rigs.
Right.
And that electromagnetic pickup is exactly what you hear as that humming noise. Light, on the other hand, just doesn't care at all about magnetic fields.
So it is totally immune.
Completely immune. Once you encode that analog audio into photons, it becomes, completely impervious to electrical noise.
So using traditional copper is basically like trying to shout a message across a crowded, noisy room where all the other voices and ambient noise just drown you out.
Yeah, that is a really great way to put it.
But this fiber optic system, it is like shining a perfectly focused laser pointer across that exact same room directly into a receiver.
Precisely. Because the laser simply doesn't register the noise in the room. And, the operational value of that immunity is just huge.
How so?
Well, in a high-stress environment, like maybe a live theater production, a technician does not have the time to go hunting for which exact cable is crossing a power line and causing a hum.
Oh, definitely not. You just need it to work.
Right, and this unit is built completely around a plug-and-play design. You really don't need any complex software configuration or anything.
It just has those simple LED link lights, right?
Yeah, exactly. Just LED lights to confirm your power and fiber connections are solid, which systematically removes human error when the stakes are at their highest.
Okay, so if converting the audio to light completely seals it off from outside electrical interference, that must also solve the problem of signal degradation over distance, right?
Yeah.
Like, it goes further.
It absolutely does, yeah. Though, I mean, the distance really depends on the type of fiber optic cable you use. The unit supports multimode fiber, which will carry your audio up to 2 kilometers.
Okay, 2 kilometers is already a lot.
It is, but if you switch to single mode fiber, it pushes that range to a staggering 20 kilometers.
Okay, wait, we really have to unpack that. What makes single mode capable of 20 kilometers compared to multimode's 2 kilometers? That is a massive jump.
It is all about the pathway. So single-mode fiber uses a highly focused laser to shoot light straight down an incredibly narrow core.
Like a straight shot.
Exactly, because the light isn't bouncing off the inside walls of the cable like it actually does in the wider core of multimode fiber. It maintains its signal strength over massive distances.
Oh, I see.
And, it does all this while maintaining a frequency response of 10 hertz to 29 kilohertz.
Meaning it captures the lowest rumbling bass drop down at 10 hertz, all the way up to the highest crispest cymbal crash at 29 kilohertz. And it does that without compressing or losing the ends of the audio spectrum.
Exactly. You get pristine 24-bit digitally encoded audio with a signal-to-noise ratio over 70 decibels. And that holds true whether the receiver is right next door or literally towns away.
I really have to push back on that 20-kilometer spec, though. That seems almost absurdly far. I mean, are they just showing off the technology, or is there a real-world scenario where you actually need to send RCA audio across the equivalent of a small city?
I know, it sounds completely absurd until you look at their target markets. Think about sprawling theme parks, massive stadium complexes, or even campus-wide CCTV audio networks.
Oh, wow. Yeah, a theme park is basically a small city.
Exactly. Laying 20 kilometers of copper wire to connect all those zones would be incredibly heavy. It would be prohibitively expensive. And honestly, the signal degradation would just make it completely unusable.
Right, because of all the interference we talked about.
Yeah. Fiber solves the weight, the cost, and the quality. Plus, this specific Thor unit has a mean time between failures, or MTBF as they call it, of over 100,000 hours.
Wait, 100,000 hours. That means this device is designed to run 247 for over 11 years without failing.
Right. For an AV technician at a theme park, that isn't just a technical specification. I mean, that is total peace of mind for continuous remote operation.
So, bringing this all together, for an MSRP of $1,495, this 16-channel kit is essentially letting professionals rip out miles of heavy, unpredictable copper and replace it with a pristine, digital, light-based highway.
It really highlights how rethinking the fundamental physics of a problem, shifting from electricity to light, can completely eliminate limitations we used to think were completely unavoidable.
Which really leaves you with a final thought to ponder today. If we have the technology to transmit 16 channels of flawless audio 20 kilometers through a simple, tiny beam of light, what other hardwired physical limitations in your daily life are you stubbornly accepting just because you are used to them?